Do you remember when we talked about implementing machine learning in PHP and we said there are 3 main steps? Let's go through them one by one and build our very first machine learning model in PHP. Let me go to my code. Okay, let me copy the steps. Perfect. We can even divide them into smaller steps. For example, loading the data. And then the next step would be preprocessing the data. Then we train the data and then we evaluate our machine learning model and then we make predictions. Okay. From the very first steps, loading the data. Normally when we are learning, we can even write our own data as an array. But in real world scenarios, most of the time we are dealing with CSV files, so it's better to get used to it from now. I have added the data folder here. You can also download it and bring it to your project. Right now it's just a file called insurance.csv. Normally in PHP we open the file and then we use fget.csv and we get the data from the file, but this time, instead of doing that, we are going to use the functionalities that PHP ML provides for us, because not only it loads the data, loads the CSV file, but it also gives us a lot more features. So instead of loading the CSV data normally from a file, we are going to use PHP ML's CSV dataset. How can we do that? It's very simple. Our data is a new CSV dataset. It auto-loaded for me, perfect. Then the very first argument is a file path. In my case is data and then insurance.csv. Then as a second argument, it asks for the number of features. What are features? You will hear it a lot in the machine learning world. Features are independent variables. They are like inputs. The values we give to the algorithm in order to get some output. So our inputs are called features. And here it asks what are the number of features. Let me show you our data. We have a column X and we have a column Y. X is the input. X is the independent variable, and in our case is the number of claims to an insurance company. And the output, the Y column, is the total amounts that the insurance company had to pay. So which one are the features? The X. X is the independent variable. We are going to train our model based on X, and in the end when our model is ready, we expect it to behave like this. I would give some number to it and I would say, okay, this is the number of claims that we had this year, and the model would predict the total amounts that we have to pay as the insurance company. So what should we write here? 1. The number of features is 1. But if we had some data like housing data, we would have a column like the size of the house, the number of rooms, distance to city center, distance to nearest public transfer, and so on. So in that case, if we had like, for example, 11 columns and the last column is the output, we would write 10 here. And the last one is asking if our data has a header or not. In our case, it has X and Y. We don't want to use that as the data that are going to be passed to the algorithms to be trained on. So we write here true. That's it. Now this data set, CSV data set, is going to get the data from this and it goes through the file. It says, okay, there are 2 columns. One of them is the feature. So the last one are the outputs. I'm going to use that, and it's going to provide us with a lot of great helpers and a lot of great functionalities, which we will see in a few seconds. That's it for the first step. Now, the second step is pre-processing the data. When we say we want to pre-process the data, we mainly do 2 things. The first one is cleaning up the data. For example, we normalize the numbers, we do some feature selection, we fix the empty values, and so on. And the second thing that we do is to divide the data to train set and test set. What does it mean to have train set and test set? Let's see what we want to achieve here. Our main goal is to find the connection between the features and the output, and then predict outputs based on the values, based on the features that we have not seen before. If I train my model based on all the data I have, it works perfect now in the testing phase, but when I send it out there and I want to predict some values, it's going to be really bad because it has never seen any values before. I have never evaluated that. That's why it's very important for us to have a train set and a test set. Train set is what we train our model with, and test set is what we don't show to the algorithm. Later, we ask our model to predict based on the features and inputs in that test set, and then compare the predicted value with the actual outputs that we had and see how our model's predictions are. That's how we evaluate our model and see if it's good or not. So here, my numbers are good. I'm not going to change any numbers. I'm not going to do any cleaning up for this data. Maybe for data in future we will do something like that, but for now let's divide it to train set and test set. How can we do that? Well, there is a manual way and there is an automatic way. The manual way is we can literally select some of them and copy in another file and use that for our set, or we can write a function here and use like train data and test data. But the automatic way, which I recommend, is to use the functionalities provided by PHP-ML. So how can we do it? PHP-ML has two functions that would get the data randomly and divide them to train set and test set. The first one that we are going to see for our model today is called random split. So data set equals to new random split, and the first argument is our own data. Then the second argument is the percentage of the data we want to be considered as test data. It completely depends on the number of data that we have, but normally between 10 to 30% would be a good value. In our case, I would like to set to 20%. Then the last part is actually not necessary, but in our case, because I want you to get the same values as me, we would set some seeder here. So for example, I don't know, 156, it would be our seed. So this random split would get us the same values every time that we refresh the page, every time that we run the code. And if you are coding with me, we would have the same values. Otherwise, it's not necessary. It just goes through the data randomly. But if we have the same seed, the final split of the data is going to have the exact same result for all of us. So I set 156. Now this random split is going to give me 4 group of data, 4 arrays. What are they? The first one is get trained samples, or the features or the inputs that we are going to use to train our data. So it gets the trained sample, and in order to get the outputs of training set, we can run the method get train labels. Labels are the outputs. So we have a train input and we have a train output. Now we also have get test samples and get test labels. So this function has divided my data to 4 arrays. get train samples, which are the inputs, train labels, which are the outputs for the training set, test samples, which are the inputs of the test set, and test labels, which are the output of my test set. That's it. With the help of this random split, I could get all of this, but right now I'm not going to use that. I'm going to use them when I'm going to train our data and evaluate our data. So now let's do it. Our very first machine learning model, which is based on this insurance data, is going to be a simple linear regression. What is a linear regression? Well, linear regression is the relationship between a dependent variable and one or more independent variable. In our case, the independent variable is the number of claims that happened that year, and the dependent variable is the output, the total amount that the insurance company paid. Now let me show you our data in an Excel file, because I'm going to draw a chart based on the data we have. So you would see the relationship that these data have. So let me select all of them. Then we go to insert and let's draw this one. Okay, as you can see from the chart, this is the number of claims that we had, and this is the amount, the total amount that the insurance company had to pay. Even from this plot, we can see that there is a linear regression. There is a linear relationship between these data. The more claim we had, the more that the company had to pay. So we want our model to realize this relationship, to find this relationship and give us a model. So later, for example, when we say, okay, there are 80 claims. I do not have any data here. I want my model to see, okay, there was a relationship. If there is 80, so the total amount that we have to pay is something between 200 to 300. So it would give me something from here, but it has never been trained on the data with the claims that are 80 because we have no data. That's the beauty of machine learning. It finds the relationship between all these data and then predicts value, predicts output based on inputs that we had never seen before. That's what we are going to achieve here. So let's go back to our code. Let's train our model with a regression algorithm. So how can we do that? The very first step is to create an object, new list squares. That's it. This gives us all the functionalities that we need. Now, in order to train it, we can call the method train. It needs an array of samples. So we are going to use our training set samples, and it also needs the output for those samples. So we are going to use our train labels here. Now it's going to go through all that data, find the relationship, get trained, and with this regression object that we had, then we can make prediction. How can we make prediction? Simple. All we need to do is to say predict based on some values, based on some samples. But how on earth can I know that the trained data is good or not? What is the accuracy? How can I check that? Well, if you go to the source code of PHP ML, in the source folder, you can see that it has been divided to different directories, and in one of the directories, which is called metrics, there are all the metrics that we need for regression. Here, if you look through all these data, if you are familiar with all these values, all these functions, you can use them, but the one that I am going to use is R2 score. So here I want to evaluate my model. So the score would be regression R2 score. It was a static method, so I don't need to create an instance from it. The first argument is the actual outputs. So in our case are these data. And the second argument is the predicted output. So we are going to predict based on our test samples or test inputs, and it would give me an array of outputs. I'm going to use it here in my evaluation and then echo the R2 score. Echo R2 score is score, and that's it. That's really how easy it is to train our model. So let's run our code to see if it works or not. Index.php, and as you can see, it gave me an 83% accuracy. This is very good. So let's go through the code again and let me explain everything to you what it did. The very first step was that we load the data. So we put all the data. So we used CSV dataset from PHP and we loaded our data. We set the number of features. What were features? Features were inputs of our data, and we set heading to true. Then we divided our data set to train set and test set with the help of this class, this random split from PHP library. So we passed the data and we set the percentage of data that we need to be divided as test set. In our case, 20% was fine, but you can set it to 30, you can set it to 10, you can set it to any number you want, but normally between 10 to 30 would work the best. You don't need to pass any seeder, but in our case, because we are learning, we are going to expect to have the same data. We pass some seed to this, so even I run my code many times, I will still get the same data. I will train data based on the same values. But if you don't want to do that, you can remove it. This would divide our data to 4 groups: train inputs or train samples, train labels or train outputs, test sample or test inputs, and test labels or test outputs. Then based on the algorithms, this part, it completely depends on the type of algorithms that we are going to use. In our case, we are going to use a simple linear regression. So we are going to use that class list squares, and then we train based on the train samples or train inputs, and we give the outputs as well. So then our algorithm is going to try to find the relationship between these outputs and these inputs, and then when it's ready, we can predict with it. So here we can say regression predict based on our test sample. Here we passed our test sample because we wanted to check the accuracy and how good our model was. But in real world, you don't need to pass test sample. You just here pass your data. You pass, for example, do you remember when we said we want to check if we had 80, how it would be? Here we would pass that, and a score, we are going to check the score based on this predicted value and based on the real outputs. And this R2 score is a very good standard score for regression model. For classification and other algorithms, we have different scores, but for regression, R2 score works fine. And the score of our model was 83%. You can make it better, you can make it worse, but in our case, for our learning purposes, 83% is perfect. Later, now that we know, okay, this is good, I want to predict some data, I can use the same function, predict. I could say, okay, predict the value that we wanted to pass, the value that had no training data was 80, I guess. Yes, we can var dump this, var dump. So let's run our code. Let me comment that echo. Let's run the code. Okay, it gives me 301. That's exactly what we expected because we saw the chart, we saw the scatter plot. We expected our model to find that relationship and give us a value between 200 and 300, and this is perfect. This is very good. That's it for today. Let's continue with our course.